Welcome back. This is the day the Lord's made. Let us rejoice and be glad in it. In this video, I'm going to talk about the electromagnetic spectrum for my physical science class. This could be just a very basic overview of the different regions of the spectrum. So when we say the electromagnetic spectrum, we're actually talking about light and different types of light. And so we're already very familiar with like visible light, how we see the world. So, but there's other regions of the EM spectrum, other energies that the photons can have. So on the electromagnetic spectrum, you should be aware that on the left side here, as on this chart here, the radio waves, these are the lowest energy waves, and they're the longest. So radio waves is a region of the electromagnetic spectrum. On the right side here, the gamma rays, these are the highest energy electromagnetic waves. So, but again, electromagnetic is a fancy word for photons. So we can basically say there are photons in the radio section, which have very little energy, and photons in the gamma ray section, which have a lot of energy. And so we have 7 regions I want you to be aware of. So from least energy to most energy, it goes radio, microwave, infrared, visible, ultraviolet, X-ray, gamma. So radios have low energy, the microwaves have a little more energy than them, infrared has more energy than that, visible is what we actually see, it's in the middle, ultraviolet has more, X-ray even more, and gamma is even more. So again, if you think about the words too, infra and ultra, what do they mean? Infra means below, ultra means above. So ultraviolet means above violet, and infrared means below red, because in the visible spectrum, what we can actually see, red is the longest wave and violet is the shortest wave, which has the most energy. So when it comes again to the electromagnetic spectrum, we don't see these other regions. We don't see radio or microwave or infrared, and we don't see ultraviolet, X-ray, or gamma. We just see this middle section, the visible light spectrum. Everything else will be dark, all right, which basically means like right now there's a bunch of radio waves going through me, I can't see them. All right, there's microwaves going through me, I can't see them. All right, my body glows infrared, I can't see it. All right. So other cool stuff to know about the electromagnetic spectrum is what actually comes through the Earth's atmosphere. So again, our atmosphere kind of protects us from some things, but not everything. Like radio waves go through the Earth's atmosphere. This is good, otherwise satellites won't work. Microwaves and infrared generally don't go through the atmosphere. They get absorbed. Visible light goes through the atmosphere, so we can clearly see. And the other ones here, ultraviolet, X-ray, and gamma tend to not come through the Earth's atmosphere either. And one you're probably aware of is like ozone is the molecule which takes out most of the ultraviolet light. Now some does, but some does get through, but again, ozone takes a lot of it. This is just giving you a relative size, how big those waves are, how big the photon is, the wavelength of it. So like radio waves, they're like the size of buildings. They're huge, all right? You could be talking like 100 meters, 1,000 meters long, all right? Gamma rays, very, very tiny. They're like the size of an atom's nucleus, very tiny. So visible light is like the size of like, like viruses, bacteria, really tiny things. Everything glows based off their temperature, all right? The hotter you are, the higher energy photons you give off. So for humans, based off our temperature, we give off, our highest energy is infrared. We glow infrared. You should be aware about the visible light order for the homework assignments. Red has the longest wavelengths, and it's about 700 nanometers. So, and violet has the shortest wavelength, around 400 nanometers. So you should be aware of those two numbers. 400 nanometers corresponds to violet, which is one end of what we can see, and red is 700 nanometers, which corresponds to the other end of what we can see. You should also be aware, we talk about the word like ionizing and non-ionizing. It talks about how much energy it has and whether it can actually cause bad stuff to happen to your body. Can it cause your body to get cancer? So pretty much visible light is in the middle, all right? It is the boundary. If you have more energy than visible light, you're ionizing, and if you have less energy than visible light, you're non-ionizing. What that means is radio waves, microwaves, infrared, these things do not cause cancer because the waves don't have enough energy to make our body's electrons jump to be ionized, which would then result in breaking bonds, result in damage to the body, and result in cancer. So non-ionizing is like a radio wave goes through my body. So if I'm listening to 100.7 FM, that radio wave is actually going through here right now, and it hits me. Does my body get damaged? No, because radio waves have very low energy. Microwaves are also non-ionizing. The microwaves do not actually cause your body to get cancer. Can they be dangerous still? Sure, but what do? Pretty much, they're just gonna make it get warm. And if you think about your microwave, what does it do? It just heats up the food. It doesn't give cancer to the food, it just warms it up. all right? Infrared, same idea. Infrared just is going to be something that we feel as heat. It doesn't cause cancer, it just heats us up. Again, I'm not saying that they're not dangerous. Like you can have microwaves that could be dangerous. If there are too many of them, it could cause you to get too hot. Infrared too could make you too hot, but it's not going to cause cancer. Above here, ultraviolet, X-ray, gammas, these are ionizing. So if you do get hit by ultraviolet light, that photon has enough energy to make electrons jump, has enough energy to damage a cell and break it. All right, break the chemicals that are inside of it apart. Same with X-rays and gamma. So again, you should be aware that radio, microwave, infrared do not cause cancer. And for the most part, these things just make us warm. These ones over here, ultraviolet, X-rays, and gammas, they wouldn't make you feel warm. They would break things apart. So if you go take an X-ray because you think you have a broken bone or something, you don't feel warm when the X-ray goes through you. It's not like, oh man, I feel hot right here because you're shining X-rays from my body. It doesn't heat. It just breaks things. It breaks bonds. So you should be aware of just some general uses of each electromagnetic spectrum. Again, some of these are already pretty obvious, like radio waves, communication. Your cell phone uses radio waves. So when your cell phone is communicating to the cell phone tower, it's using radio waves. It's using low energy photons. So microwaves, we use these things for cooking. You know, so you put something in your microwave, it's going to just heat up the food. It's just going to use invisible light, invisible photons you can't see. They're going to hit the food and cause the water to jiggle, and they're going to make a move. Night vision goggles, they work on the idea that we can see infrared. My body glows infrared. So if you're wearing night vision goggles, you could see my heat signature. I glow, all right? I glow infrared. We can also use infrared sensors to detect if we're having energy loss or someplace in the house. So if you ever have some energy audit of your house, they might bring their night vision goggles and they'll look at your house and take a look and see if any place looks warmer than the other ones. They'll look up at your ceilings, they'll look at your walls, see if any place looks like it's hotter than the rest to show that heat is coming in or out. So that's kind of cool. Again, visible light is how we see the world. Ultraviolet, I have tanning on here, but ultraviolet is also can be like can disinfect or sterilize an area. So like if you take, for example, if I want to clean off some goggles from like anything that might be on them that's actually growing like a bacteria or keep them safe, I could just put them in like a cabinet with some ultraviolet light and it would just disinfect the surface. So because ultraviolet can kill things. X-ray, again, we use these things for seeing bones. Scanners at airports too, we look through. Gamma rays, pretty much killing cancer treatment. We can make photons have so much energy that we just fire them at some place in the body and destroy whatever hits right there. All right, so again, I just want to give you a quick overview of the different regions of the EM spectrum. Again, from radio to gamma, radio has low energy, gamma has high energy, and this is the order that they go in. Again, visible light is kind of the boundary between ionizing and non-ionizing. These guys here, radio, microwave, infrared, they don't cause cancer. These guys do. All right, God's peace.